So as for the module 4 of the cybersecurity course, of this first cybersecurity course will cover cryptography concepts and VPN. So in this module, we will look into VPN infrastructure, its concept, characteristics, the IPsec framework, and then we'll configure site-to-site VPN using Cisco routers. We'll use your knowledge in that you attained in the CCNA program, and then after that, we'll proceed on the Security Plus material. We'll compare and contrast basic concepts of cryptography. We'll look into hashing, symmetric and asymmetric algorithm, and other algorithms that are other cryptographic algorithms. Okay. So, so first part is implementing virtual private network. At this point, VPN should be well understood. Okay. During your Cisco days, we define VPN as a private network through the internet, right? Securing the private network through the internet, there are couple of encryption mechanisms to be applied, security policy to be applied. We will discuss that further as we go along. Okay. Just as an overview, just to make sure that you indeed understood what VPN is. Example, Celerio, if you remember that shared drive, that resource drive, you can access that if you are into the campus, right? So that is a private network, okay? A resource that is in a private network. So how is it possible that you at home, your laptop, be able to access that Celerio? Well, it will be possible if there is a VPN set up in your computer and so as to Mapua Makati. Okay, that's how VPN is. For you to be able to access a resource that is in a private network through the internet, one means is through this VPN. Okay, now it's very popular. Okay, like during this lockdown, what Mapua did, there are VPN set up or configured to employees to their laptops. Of course, VPN actually in the campus is already configured there. So the only way to work on one of which is to set up VPNs on uh, those devices used by teleworkers or employees, like in this case, employees of Mapua. So before we proceed on the setup, let's have some these terms in relation to VPN. First, very popular framework used in VPN is the IPsec. Okay, also known as Internet Protocol Security. In the IPsec, what we have here is uh, there are suite of protocols. Okay, we will look into this later. And the use of these protocols is to provide that security. Okay, maybe through security through authentication and encryption of the packets. Again, what we mean by packets is our data with added information. This IPsec is open standard. Again, open standard means it is used not only by Cisco, also but other vendors. Okay? So what happens in the IPsec is it creates a tunnel. Okay? It creates a tunnel. So for example, I have two buildings here. Say Makati and okay, okay na MK. MK for Makati, and then say this is for Intra. So what happens in the IPsec by concept is if there is a data to be transmitted through the internet, this is the internet, the cloud, what the IPsec will do is to create a tunnel. What we mean by tunnel, this tunnel, it represents a security policy. Okay, so what we have here are a series of encryption mechanisms, authentication algorithms, key management. Okay, so and these are the means for us to protect data being transmitted by concept here in the tunnel. So in the VPN and using IPsec, what we do is we establish a contract. Okay? So it is a contract between two parties. For example, Mapua Makati to Intramuros, it will have this agreement. What is there in the agreement are um, also, okay, what will be our encryption mechanism? Okay, in your information security one, and we'll have a review of that later. There are different encryption mechanisms out there. Okay, so in the security association, we it is being agreed by two or more branches. Say for example, like Makati and Intra, they are to come up with an agreement on what are those encryption mechanisms to use. Okay? Very important. The example in the agreement is that it should match, right? Okay? What I mean by match, example, if you were to work someday, what you know is the same as what the employer knows. Like, and here also in the class, what I know as a teacher, you as a student, it should be same. Okay, that's what is there in the agreement. Example, if I say, you know that the passing is 70%, so I should know also that that is 70%. Same thing here in the security association. For example, um, what is being agreed upon is that in Makati branch, the encryption algorithm to be used is this. Okay, this. So in Intra, it should be same. It should also use this as, say, encryption mechanism. That's how it is. Ano? One very important thing to take note in a security association. Okay? So security parameters are set up here in the security association. My example is not, it's not as simple as how IPsec works. We'll explore on the uh, details of the security association as we go along. After you define the security association, after you define those encryption and then means of authentication, the key management to be applied in both parties, you list it down to a crypto map. So you have a mapping of security policy. Okay, this mapping is to be applied in an interface. During the configuration, we will be able to visualize how this crypto mapping is. So, details about IPsec. Again, IPsec is a private network through the internet. Conventional, the old one, the way we connect or establish a private network or connect our branches, you learned this during your Cisco 4, is through leased line, right? A dedicated connection, guaranteed rate, faster. That's an advantage. Disadvantage is expensive. There are other cheaper options such as frame relay, okay, or ISDN, but these usually are legacy already, outdated. There's a new one, Ethernet, okay. Actually, not a very new, but it's a popular one of popular technology of establishing a private one, Ethernet, okay. But a much cheaper means of connecting branches or connecting private network is this VPN. Okay? Because take note, all I think I can no, not all. Most companies, private companies has internet. Okay? So, if they have branches and they want a much cheaper option, they may resort to a VPN. Okay? Requirement for the VPN is that the router should be able to support this. A router should have these features. And even small business types has VPN setup nowadays. So with VPN, it's again lower cost, more flexible, okay? Also easy to manage. And then again, it uses the tunnel topology. Again, tunnel represents those means you set up on your device, network device, say the router, in order to secure your data, in order to make the data transmission be private through the internet. So again, in VPN, what we do uh, in a router or in a server is we implement or set up security policy. And then this policy, its agenda would be, would have, in terms of security, has something to do with confidentiality, okay, integrity, and authentication. Okay. So again, in authentication is we ensure that whoever are the only authorized a user are the only ones that can send data through the tunnel. Okay. Providing this, like with IPsec, this a way to authenticate is by providing a pre-shared key. Okay, sort of a password between two parties, say two campuses or two branches. Confidentiality is that there will be an encryption mechanism. Okay. Uh, to be applied during a cryptographic algorithm, okay, much better term, uh, to be applied to the data during transmission, okay, or in the data in transit. And then in integrity is these are mechanisms that ensures that the data has not been tampered or altered. Okay, again, I mentioned already that in tunneling is the concept we use in VPN that indicates that the data transmission is secured by providing encryption mechanism or applying cryptographic algorithm. There are two uh, types of VPN, site to site. Example, if the setup of Mapua Makati to Mapua Intramuros is VPN, okay, uh, that's a site-to-site VPN. Okay, usually again used to connect offices, branches. Um, with remote access VPN, these are usually used by teleworkers. If you notice, our phone has VPN. So if it is, for example, your phone is set up to connect, say, to Mapua network, so that's an example of a remote access VPN. Or say your laptop has this what we call as a Cisco VPN client software. So it is set up to connect to a private network, say Mapua Makati or Mapua Intramuros. So that's an example of a remote access VPN. I have here an example of a VPN client that Cisco has. Okay, this one also another example of a remote access VPN software. So next is GRE. So there are two site-to-site tunneling protocols. There's the IPsec, which is the most popular one because other vendors uses IPsec. Cisco supports IPsec. Cisco came up with its own tunneling protocol. It's called GRE, Generic Routing Encapsulation. Okay. With GRE, what it does, it hides the content of a protocol, say IP or maybe routing. Okay, example, take note, say, Mapua Makati to Mapua Intramuros, it goes into there's a private connection, private network already established in the internet. And take note that within these two routers, we learn in Cisco that they send out updates, right? Routing updates. So it will be passed on the VPN tunnel. So GRE can hide the content of the routing updates. Okay. So that's the use of this GRE. Okay, it hides the contents of another protocol, say IP or routing protocols within the tunnel. Okay. Um, GRE is not as secured as compared to IPsec because it does not provide encryption. Okay. So for us to better see this, let's look into the setup of the GRE. So to configure GRE, you need to establish a tunnel interface. It's a logical interface. Okay, it's not a physical, you don't see it. And then this is what you do here is you assign an IP ad. So example, Mapua will set it up. So Mapua will be the one to assign the IP ad for the tunnel. And then set up the tunnel source and then tunnel destination. And then to enable the GRE, you type tunnel mode GRE IP. I have an example here. Okay, so for example, R1, say Mapua Makati, that is R1. R2 is Mapua Intramuros. So R1, Mapua Makati has this public IP of 209.165.201.1, and in Mapua Intra, so say this is Makati and say this is Intra. So in Intramuros, it has a public IP of 209.165.200.225. Okay? So to establish the GRE, what Mapua administrator will do is to set up a tunnel interface. So this 10111 and 10112, that is assigned by the network administrator of the company. Okay? So uh, so this is the tunnel interface IP ad. So to set it up, you go to the interface tunnel 0 and then you type IP add and then the IP address to assign. And then tunnel source, the interface label of this source of R1. So whatever the physical label interface you have in connection from R1 going to the internet, okay, uh, you type it here. And then tunnel destination, the public IP of the other end. Say in this case, Intramuros. Okay, and then you enable GRE by typing tunnel mode GRE IP. Okay, you do that also on the other side. Okay, when you for you to know if it works, what you do with the router R1, you trace route a a packet going to R2. Example, there's a 192.168.5.2 here. Trace route mo yun. Trace route 192.168.5.2. What you should see in the trace route is this 10.1.1.1 and not the public IP. Okay? So, what happens in the GRE is that the GRE hides this public IP, that this information. Okay? It hides this specific information with this tunnel interface IP add we've set. Okay, again, GRE do not provide any encryption. So that is why, still, with VPN, best to use IPsec. Okay, you may use a combination of GRE and IPsec. Okay, so again, once you're every time you do your configuration, always check your configuration in the running config. So now IPsec. So in IPsec, it's a framework, again, open standard developed by IETF. And what we do in the IPsec is um, we define algorithms used to encrypt, decrypt, authenticate packets. Okay, so and also we also set up key exchange and key management protocol to use. IPsec supports a range of cryptographic algorithms. It's up for the administrator of a company to decide which algorithms to use in their VPN setup. So I have here a list of different uh, IPsec that Cisco router supports. Okay, so for the IPsec protocol, there are two options: AH, Authentication Header, sorry, Authentication Header, and ESP, Encapsulating Security Payload. You may use combination of both. For confidentiality, uh, these are the encryption mechanisms that addresses confidentiality. We have DES, 3DES, AES, and SEAL. So this is from the in order from the weak encryption. So DES is a weak encryption, and then to the stronger encryption mechanism, SEAL. For integrity, the one that addresses that are our hashed algorithms, MD5 and SHA. And then there are two options for authentication, PSK and RSA. And it is very important that for these mechanisms there is a um, key management mechanism to apply, and for that, or key exchange, and for that we have Diffie-Hellman to handle that. We will discuss this further, okay, in part 3 of this module. Again, DES is from the least secure, SEAL is from the um, most secure, okay. Uh, in each of these encryption mechanism, there's this key length. The longer the key length, the better, the more secure it is. Okay, we will discuss this key length again also in part 3. For integrity, again, MD5 from the list, most secure is Hasha. And then PSK RSA for the authentication, and then Diffie-Hellman uh, algorithm. Uh, Recommended for, say, for AES, DH2, DH5. Okay. So for IPsec framework, we have two main protocols, the AH, Authentication Header, and the Encapsulating Security Payload. For the AH, it provides authentication, but it does not provide encryption. Okay? Um, so this AH and ESP, these are the protocol that the IPsec has to secure our payload. What we mean by payload is our data. Okay? So, if we do not set it up, if we do not set up an AH or an ESP, all data to be sent are all in plain text. Okay? So, and besides, when we set up VPN, it's a requirement to work on this. Okay, so there. So we have an option, no, AH. In AH, it only addresses authentication, okay, but it doesn't provide encryption. So a much better option is the ESP. In ASP, it provides authentication and encryption as well. It ensures that the data is really indeed protected. Again, what we mean by payload data. When you hear the word payload, that's just the data. So, in ESP, which is a much better option for um, a much better protocol under IPsec, first thing it will do is to encrypt the payload, the data, using DES or 3DES or AES. Okay. Once it is encrypted, okay, once the data or payload is encrypted, it is being hashed. The hashed, its agenda is to provide integrity to ensure that it is not being altered, right? Also, authentication. There are two options under integrity. An admin may apply an MD5 or a SHA. SHA is much better again as compared to an MD5. Setting up ESP and AH is preferred. Okay, both of these protocol. And then for the IPsec, we have these two modes, transport mode and tunnel mode. If the setup of the IPsec is transport mode, okay, uh, it only encrypts the data. Okay, again in transport mode, what is only encrypted is the data. Okay. In tunnel mode, what is encrypted is the data and the header. Those added informations. Okay. So those are two things you need to take note. Okay. Data only transport mode. Tunnel mode is the header, the IP, for example, and then the data are being encrypted. So in setting up VPN, first thing to do to consider is to determine the IKE phase 1 and phase 2. IKE, IKE, it stands for Internet Key Exchange. Okay, what we write down in the IKE, example in phase 1 are the security association, the parameters you are to set up during the connection, establishment of the connection. And then for the phase 2, it's for the security parameters for the payload or the data. Okay. Also in the IKE, this is very important parameters or to consider are to authenticate the peers, say the two branches you are to establish the VPN and negotiate the encryption parameters. Okay, negotiate the encryption parameters. So next. So again, we have two IKE phases. Phase 1. So in phase 1, we negotiate a protection suit and its agenda is for the establishment of the connection. Once phase 1 is established, then it proceeds on phase 2. In phase 2, you define security parameters known as transform sets and its main agenda is for the payload. Okay? So in VPN, the way it works, it first works or process phase 1, establish connection, then phase 2 for the payload or data. So, to set up IPsec, first thing you need to do is to send interesting traffic. We use access list for this. And after that, we set up phase 2 under policy. We'll look into this later when we configure the site-to-site VPN. Okay. After you establish after you authenticate the peers, negotiate ISA security association to secure the communication channel, to secure this communication here, okay, secure the connection establishment. Then it will move on to phase 2, negotiate the parameters for data protection, and then once IKE phase 1 and phase 2 is successful, that is when data transfer starts. Okay, and then once uh, the data transfer ended, then what happens is that the IPsec tunnel is to be terminated. Okay, again, we use access list to identify interesting traffic. So in phase 1, for example, let's say, okay, for routers A and B, so what will be our encryption mechanism? What will be our hashed algorithm for integrity? What will be our pre-shared key if we were to use PSK? And then again, very important, the key management. So what Diffie-Hellman group we are to use? we may set up a duration for this policy. Say if you want to use it lifetime, meaning forever, that will be the policy to be used by routers A and B. So we write down lifetime. Okay, if not, we can write a value in seconds. Okay, so make sure that the policy you define for phase 1 for both routers are the same, or else it will not work. So phase 1 again, its main agenda is to establish connection. Okay, so first thing it will do is to authenticate peers. So during this authentication phase, there are um, data to be sent. Not the data, there are data, for example, password or the pre-shared key, and needs to be protected as well. So for phase 2, this is again where we write down security parameters for our data. Okay. So I have an example here. And then once phase 1 and phase 2 is established, that is when the IPsec session starts, meaning data transfer. And once data transfer ends, then IPsec IPsec tunnel will be terminated. So this ends part 1 of the IPsec. I hope to see you on part 2 for the demonstration of the site-to-site VPN. Keep safe. Thank you.